Yeah. Thanks, Daniel, for the introduction. Actually, I will continue with open source and open standards. So next generation emergency services, this is a story of open standards. This is my rough outline for my presentation. So I'll tell you how it began. So there's a nice story behind that. Then I will explain to you next generation emergency calling. And then we go through a step-by-step emergency call. Then I show you a simple configuration. Actually, that was a configuration we used for proof of concept. And then a short summary on that. But first of all, who knows about the next generation 112 or next generation 911? Just raise your hands. Wow, at least a few. So perhaps it's something that's not new to you. But first of all, let's talk about this nice story, how it began. So it was November 2011 when I joined an interoperability test event. It was in the US. It was my first event on that emergency calling kind of thing. And there were a lot of functional elements there being tested, and also some SIP routing elements, where some companies providing their soft switch solutions with IP interfaces and SIP support, but there was a lack of support of service URNs. And the service URNs, you will see later on in my presentation, are mandatory in that context, because if you want to dial emergency services in the future, you don't use a dial string, you use just a service URN. Perhaps it's just a button, a symbol you press on your phone in order to get connected to fire, ambulance services, or police. So this is a very key element, the service URNs, and it wasn't really tested there. So people said, okay, we don't support that in our systems. And actually I was wondering if Kamailio could do the job. And I have a good friend in Austria, Klaus Darillion. Who knows Klaus? Oh, cool. He sends best regards to you. So I talked to him and asked him to implement this service URN patch, and he told me, well, you can do it on your own. It's not that complex. And actually, a few weeks later, we had this patch ready, and we checked it in, and here is just downloaded from the repository yesterday. So it's, yeah, I think it was the 8th of February 2012. That was the day when Kamailio started to support the service URN. And actually, since then, all the interoperability test events went quite well, because we had a very good routing element that supports service URNs. But back to the topic. So it's next generation emergency calling. And it's, sorry, that was wrong. It's something that changes our lives, because today emergency calling is just voice. So if you dial an emergency number, you get connected to the emergency center, but you can just speak to the emergency center. You have no way to send additional data about your location, for instance. There's no way to send images. There's no way to have a video chat. There's no way actually to chat for some people that are deaf or hard of hearing. They would need to chat, to text, to an emergency center. So some solutions are around in European countries where you can use the SMS in order to contact an emergency center, but still we stick to voice. And in the future, this next generation emergency calling intends to enable the public to contact an emergency center via the audio, the video, and with additional data, especially with location information. So location information is used for routing purposes and also for dispatching purposes. So the idea is to get a very accurate location to the emergency center, that dispatching can be quite simple, because then people would know where to send the fire brigade, for instance. And all this is kind of open standard, so it's based on the ETF ICRIT work. So ICRIT is a working group in the IDF that deals with this emergency context resolution with internet technology. And the basic blocks we use here is our SIP, RTP, the HELD protocol, it's HTTP-enabled location delivery, and the LOST protocol. LOST means location to service translation. I'm going to talk about that anyway. And recently, in Europe, we started within the special committee MTEL, the ETSI standardization committee, a new work item which plans to release a technical specification that describes all these core services that we need for the next generation emergency calling. And in addition, a technical report that describes how to do the interoperability testing. So it's kind of a CPIT event, perhaps for a special domain, where we just test those things that support the machine. In addition to that, we have in the US the National Emergency Number Association, and in Europe the European Emergency Number Association, and they have published long-term definition architecture documents. So they're quite around quite a long time. So for instance, in Europe, we released this document in 2013. And in the US, we had it much earlier. So I was mentioning this interoperability testing in the US. So the first documents were released in 2010 or so. And last year and this year, we had quite interesting interoperability testing as well, with support from ETSI. We had this kind of plug test. You may have heard about that, where we tested this nice infrastructure, these routing elements, and we also tested voice over LTE emergency calls. So it was quite interesting to see how things interconnect. So we had legacy technology there. We had voice over LTE infrastructure there. We had just VoIP calls coming in, and we had this centralized idea of routing. So yeah, here we have those core services, and try to put it into one picture. So on the left side, you see these originating networks. So they will change in the future as well. So today it's just something that's BSDN. Even if you do a VoIP call, it gets routed via the BSDN to an emergency service center. In the future, it should be different. It should be possible to connect directly from VoIP service providers' infrastructure to kind of emergency service IP network. Perhaps we have some private networks, unified communications there, and for sure we'll have the voice over LTE. So this is more or less the public side. We perhaps have two different roles in this emergency service IP network. The one is the emergency call service provider, and the other is the PSAP service provider. So this actually depends on how things are regulated and what legal issues have to be considered. But just consider this as an IP network, and signaling here is all SIP. Then we have some elements I'm going to talk anyway. So we have border control function, location information service. And this one, this is the interesting part. This is the emergency service routing proxy. And actually, this is the element that needs to support the service URLs. And on the right side, we have the public safety answering points. This is the technical name for the emergency control center. Yep. Just go through these elements. So the emergency service IP network, it's a managed IP network, and already mentioned that this emergency call service provider and PSAP service provider are part of this emergency service IP network, but they have different roles or different scope of responsibility. So one acts as transit network and provides a security perimeter, so the first line of defense. So this part can be provided by a telco service provider, and this is perhaps a network that is organized or run by the agency itself, so it's the PSAP service provider. And here it also depends on how things are structured in terms of PSAP models. So I'm not familiar with any country in Europe, but there are different, at least two different types of PSAP models. So for instance, in the UK, you have a stage 1 PSAP. It's by British Telecom, where all your emergency calls are routed to, and then they forward the calls either to the police, to the fire brigade, or to the ambulance. So very centralized, and The other model, which we have in Germany or in Austria, is where you have the federal states. They are separated. They are responsible for that. And you have emergency centers for the different organizations. So you have one for the ambulance, for the fire brigades, and one for the police. So it's really different, and it would then mean, okay, I have to find the right PSAP. I have to route to the right organization in such situations. Yeah, the border control function, it's an application layer gateway or the point of interconnect. So this is where calls are routed from the public. And beyond that, we have then these open standards that forward calls to the correct PSAP. So yeah, they do some protocol sanitizing and perhaps also some topology and feature hiding if this is necessary. For instance, a call transfer from one call emergency center to the other emergency center can be a bit different or a bit difficult, so we want to hide that from the public. It's also a secure entry point, plus additional features that a commercial border control function or session border controller would not support. So for instance, the call taker has the ability to just mark a call as suspicious call, so it can say, okay, this guy just calls me every minute, so I just want to block him and don't get annoyed from him anymore. So this is some special features. Another important element is the location information service itself. So it stores a location against some kind of key. So here is just a database that provides wired addresses, for instance, or wired connections. Or nowadays, it could be something that's received via advanced mobile location. You may have heard about that 1 year ago. Almost 1 year ago, Google announced this special feature, and if you have an Android device and you do an emergency call and the country has this feature enabled, then the Android device would check the dial string of your dialing, for instance, in Germany 112 or in Austria 144, and would then send a data SMS to a central service providing location information as GPS location. So this is around since almost 1 year, but not all the countries are supporting it. But it's a great help for dispatching because people know very accurate location in the control room about the calling person. It returns a kind of present information data format location object. So this is standardized. It's an XML structure, and there are RFCs for that. Yes, the most important one is the emergency service routing proxy. So there's where Kamailio comes in. So that's the core routing engine. And that one actually uses another functional element, which is the ECRF, which I'm going to talk next, in order to get information about the next hop. So how to route an emergency call. So can be something that is based on civic locations, or can be something that is based on the geolocation. In addition, this has some special functions for that domain. So, for instance, you can set policies in order to reroute or retarget calls depending on the time of the day or the state of the emergency center. So if there is an overload situation, for instance, you can say, okay, let's forward a call to somewhere else, to a neighboring PSAP or emergency center, and things like that. This happens today as well, but it's done by the telco service provider typically, and the control room just calls some guy from the telco service provider and say, okay, now switch to plan B because we have an overload situation. With that technology, you are able to just set it as control room, and we use also SIP technology here in order to provide status information. So it's subscribe, notify kind of thing. We have this emergency call routing function. So this is the GIS database actually that provides a mapping. So if you have a certain location, then you need to route to the nearest emergency service. So like in Austria, we have these federal states, and this GIS database just stores the service boundaries of the PSAPs, of the control centers, and then it just does a point polygon operation, finds out, okay, how the router called to. So actually the input for this is based on the IETF loss protocol. It provides the location plus the service URN and returns the URI of the next hop. Yeah, and as I said, it maintains emergency center service boundaries. So these are polygons. Today, it's based on area codes. So if you dial an emergency number here in Germany, then you provide also your area code you're dialing from, and this is then used for routing. It's a bit different for mobile-based or mobile originating calls. So there we get already some location, at least of the base station. Yeah, and mappings can be for the emergency response organizations, but also for other services. So actually this protocol, the loss protocol, is also good for finding out the next pizza service, for instance. Yeah, here's an example. This is, I just used Austria because it's a small country, so it fits on the screen. So these are our federal states in Austria. We have 9 federal states, and here's just an example. So for instance, this is the state of Lower Austria, and I have an example. If you use the service URN service SOS.fire, for instance, it would then perhaps map to zip psub at blue.org. So for this area, and this is Upper Austria. And here's an example for the ambulance service. So if someone is calling here for the ambulance service, it would map in that area to zip psub at red.org. Yeah, this is also very important federal state in Austria. This is where Arnold Schwarzenegger is from. You may have heard about Arnold Schwarzenegger. So this is Styria. Yeah, as I said, in Austria, the Austrian states are responsible for provisioning emergency services. So you need to map to different organizations in different states. And we also have these different organizations within the states. So it's quite difficult in Austria. It's much easier, for instance, in the UK. This example shows the service boundaries based on the borders of the Austrian federal states. But some of the services are at county level. For instance, the fire brigade, they are organized in county level, so you would have to map perhaps to a lower level. Yeah, that's also some important thing, and here comes Frequentis. So what we provide are these psub CPs, or the control room infrastructure. In the future, such infrastructure or such customer premises equipment needs to support multimedia. So it's not just audio. You will be able to receive video and real-time text, and also messaging. So the difference of real-time text and messaging is just like SMS. Real-time text is you see if someone types a text. So this is in order to react much quicker, because the control room, the call taker, would then just see, okay, there's someone typing a text, and can also think of how to proceed. Yeah, to explain it much better, we just go through an emergency call. The first step is, for instance, Alice is dialing an emergency number for the fire department. So in Austria, it's 122, which originates from the PSTN. So this is just legacy technology, just for the sake of this presentation. There can be different originating networks as well. So the technology on the right side deals with any of those originating parts or networks. So she dials an emergency number, call gets routed. So the emergency call routing service provider knows how to get to this entry point. The gateway here also converts the service to the service URN, or inserts the service URN. Instead of 122, it would be in Austria then service URN.sos.fire. This passes the PCF and then gets forwarded to the ESRB. So what we see here is just an invite with the service URN, and we get an identity. So it's Alice. In this case, it would be a number. Next step is if the ESRB receives an emergency call, it requires a location. So some technologies may already provide a location, or some originating networks. In this example, it's an location information service that provides this information. So what the ESRB needs to do is to query this location information service using the health protocol. So what actually is provided is the identity. So the health protocol has an identity extension. So it uses just the CPURI here. And the response is a location by value or by reference, or in this example, it's both. So we have here the location URI, so this is by reference. So you can use this URL and get the location from the list anytime you send a request to it. It's a simple GET request. And this location info part is the PTF flow, the presence information data format a location object. So it's an XML structure which provides location by value. And this list, as mentioned before, may be able to receive accurate location updates via the AML technology. So if this is from a mobile phone, for instance, then it would just provide updates with more accurate locations. So we got the call to the ESRB. The ESRB has now the location and the service URN, and next step is to find out where to route the call to. So we need to route an emergency call to the right PSAP. So in this case, it needs to be the fire department, and it needs to be the fire department of the state of Lower Austria, for instance. So it's psap@blue.org. You see some different requests here. We now use the loss protocol. It's also an XML structure. And we do a find service request. We provide the location and the service URN. And this ECRF is more or less a GIS-enabled database and does this point of in polygon operation. So what we get is the next hop URI. And in the response, we also get the service boundary. So the requesting part would also know the area of responsibility of this organization. So we have, at the end, a CPURI and know how to route the call to, or where to route the call to. So the ESRB just then inserts this additional header field. So it provides a route header, which points to this PSAP. It has still the from header inside, and it also provides the geolocation header. So as soon as the call is routed to the emergency center, this call taker can just use the location reference and then get the accurate location from the calling party. And further updates are also possible because we have a reference and we can still get this from the location information service. So all these steps are based on open standards. They are around and are waiting for being implemented, actually. This is a very simple example. So the first step, I'm sure there are better ways to do, but this, as I said, was the first proof of concept we did. So the first thing we need to do is check for the service URNs. So here we just jump to the route sections for URN, and then you see here we're just checking if you got a service URN and if it's an invite or a message method. And then we do just some simple routing, and this proof of concept was based on an external Perl script. So we had an external lab that did all the steps and actually provided a destination URI and then the route header information back. And here we would just add or insert the route header, and then we just relay. So it's really basic operation, and actually today I would do it in a different way. So for instance, using the HTTP client module in order to get that information. Sorry, the next one is the Perl script. So what we get here is from Kamailio is the request URI and the from URI, which is actually used for these queries I've shown before. So the find service request and the health request. So we have the identity, we have the service URN, and with both we can get the next hop. And yeah, here we would just send an HTTP request to one of the services, and the information is then just provided as a variable back to Kamailio for routing purposes. Yeah, just summing up. So what do we get with this next generation emergency services? We have location-based and policy-based routing. So we have certain elements that support this, and it's based on open standards. And it allows for centralized routing and mapping. So this is very key in emergency services. You need to do this routing and mapping. Today, as I said, it's area codes. Now in the future, it will be polygons, and you get the location with an emergency call. Kamailio is the ESRB SIP routing engine. So it's really often used. So I mentioned these plug test events, for instance, and I know from other research projects in Europe dealing with that next generation emergency services, and they also implemented all these elements. And yeah, the ESRB, this is, or actually all I know, which work with open source, they use Kamailio. And yeah, it can be simply combined with some external app for getting the next hop or for rerouting purposes, or perhaps new modules can be implemented. So the interfaces are described, the protocols are there. Yes, standardization and interoperability testing continues. As I mentioned, we have this work item at ETSI level, and I believe that we can provide a first draft of that technical specification by end of the year. And I think after that, there will be an interoperability test event, also hosted by ETSI. So everyone who wants to implement such things or needs to implement such things, you're invited to join. And yeah, what we do in Austria, this is also quite interesting, and perhaps a volunteer for a dangerous demo. This is an Austrian pilot for deaf emergency calling. So what we've implemented is a chat app based on WebRTC, and in the back end we have this ESRB based on Kamailio and the ECRF, and this is what we want to start this year in Austria. So currently it's being tested by some control rooms in Austria, emergency control rooms, and also the Ministry of Interior is quite interested on that. So it's there, it works, but it's not ready for being tested with citizens in Austria. But yeah, perhaps I can show it. If you are interested in that, just let me know. Yeah, here are my contact information. So either Frequentis or the INA email, it's just wk@ina.org. Thanks a lot, and enjoy the coffee break.
Thank you, Wolfgang. Questions? We have James, of course. It's already in a rush emergency situation.
Yeah, you know, Wolfgang, you're going to have to do a dangerous demo now.
Yeah.
An emergency. In fact, we're probably going to have a couple of emergencies during the dangerous demo, so you just need to be ready for that. Why is it that the Austrians are just so good at doing things like emergency calling and enum and things like that? It's crazy. Don't answer that. I've got another question, which, what's the current status of emergency calling for nomadic SIP VoIP users that don't have mobile phones with GPS in? What's the current best solution for that?
I think that's quite difficult. So I'm not sure if there is the golden solution for that. Personally, I would say voice over LTE is the golden solution. So if you are nomadic, yeah, and if you get connected to a voice over LTE network, you are in a local infrastructure, in a national infrastructure, which would route you to the best emergency services. And actually, voice over LTE uses the same. This CSCF, this emergency CSCF, is kind of emergency service routing proxy, actually. And there's also the use of service URNs there. And they also provide location information based on the presence information data format location object. So it's I think, part of the voice over LTE emergency calling infrastructure already. So my best guess is that this is the solution for the nomadic VoIP calling.
Yeah, I love the way that BT deal with it, which is if they don't know where the endpoint is, they just send the call to a specially trained PSAP, who then asks you where you are.
Yes, but PT might be different because it did.
Well, BT and they charge you 10 times more for the.
So what I know is if you have unified communication solution, for instance, so soft switch or private network kind of thing, then today VoIP still gets converted to PSTN, and then you're out, and the location is your, let's say, exit point.
Okay, another quick follow-up question, because we all want to go and have coffee and things like that. Have you heard of anybody abusing or misusing the Android location service thing to get handsets to release their GPS coordinates when they're not supposed to?
Yeah, really good question. So AML works like this. So if it needs to be enabled on your device. So this is what Google does, and
but it doesn't have to be enabled. That's the whole point. If
it has to be, it has to be.
You know, it's in the cap.
Maybe others having questions.
Oh, sorry.
Let's talk about it during the break, okay?
Yeah. Okay.
Ole coming with Swedish rules back. So okay, one more question. Anyone here interested in emergency services? Otherwise,
Well, you have to make room for yourself, right? You mentioned filtering emergency calls earlier. A few years ago, I worked with the national Swedish emergency calls infrastructure, and the policy there was never, ever to filter any call. And if any provider started filtering, they would be sued like crazy.
Yep.
Because they wanted all the calls. So I'm a bit curious about filtering emergency calls.
The idea here is that it's just something that would enable a control room to reduce the amount of calls per time. Yeah. So it's not just blocking it. It just says, okay, I know this guy. He's always calling me, and he has no emergency. So once he's allowed to connect, yeah. But if he does it another time, then it will be blocked because this guy is blocking resources. So they need that.
okay, last question, Fred.
Another one?
Sorry, and just my Americanness on this one. So you guys wouldn't just go out and like arrest that guy instead to stop him from making? I mean, that's the American way of doing it. You know, they call 911. It's not an emergency. You make it one. And
yeah, it's quite the same in Europe, but sometimes it's not easy to identify such persons. Yeah, because some of the countries in Europe still allow that you can do an emergency call without a SIM card. So because the end devices would allow that. And
okay, thank you, Wolfgang. Very interesting and confirming.